So 7.2, it leads us to the Cartesian coordinate system, and we're going to combine 7.1 and 7.2 in 7.3. So we're putting that formula stuff kind of on the back burner, okay? And we're just going to look at the coordinate system. So the coordinate system is just a graph. And in the past, when we've graphed values, it's been on number lines, right? So you could say you could graph it on a vertical number line. We've mostly used horizontal number lines like that one. Now for vertical number lines, usually would say roll, right? In the middle there's 0. And as we go up, the numbers get more positive. And as we go down, the numbers get more negative, right? So if I were to look at these values, this one right here would be -3. Again, I'm looking at that vertical number line. And if I went up from 0, of course, 1, 2, 3, something like that, then I would have 3 right there. So it's a vertical number line. And then we got this horizontal number line as well. And horizontal number lines to the right is positive, and to the left is negative. So again, looking at values to the right, 1, 2, 3, that would be 3 right there. To the left, we got -1, -2, -3 here. Okay? So as long as we understand this concept of two separate number lines, then we can actually graph two variables like we looked at in 7.1, where we combine these two number lines to create the Cartesian coordinate system, which looks a little bit like this. Now, again, these are two number lines, okay? Now, what we need to understand is that this, I'm going to look at the horizontal number line here first, okay? The values on the number line, and we see this vertical number line going through it. Now, wherever that vertical number line goes through it, that's actually where 0 is on the horizontal number line, okay? And then again, as we go to the right, we get more positive. To the left is negative. So that'd be 1, 2, 3, 4, 5, we'll say. And to the left would be -1, -2, -3, -4, -5. We'll go that far. And we can see, like, if you could ignore this vertical number line, it just gives us a horizontal number line, right? Now, we've put this vertical number line through the 0 on the horizontal number line right here on purpose. It's consistent. It's always like that. So that we know that even if it's not labeled 0 right here, which it isn't usually the case, so you wouldn't expect to see that there. So you know where 0 is on the horizontal number line. Now it works the same way with the vertical number line. I would say, well, this is my vertical number line. This would be the 0 value. And again, as I go up, these values get more positive. As I go down, they're going to get more negative. So from 0, I'd go up 1, 2, 3, 4, 5. So I get 5 right here. And as I go down, I get more negative. -1, -2, -3, -4, -5. And, excuse me, this sets up the Cartesian coordinate system with two number lines, one vertical and one horizontal. Now there's parts of this Cartesian coordinate system that we need to understand or know, at least for the homework, you guys. Well, yeah, let's look at these different parts, okay? Now the horizontal number line, we need to become familiar with what it is and what it represents. Now, in the last section, we looked at relationships of x and y values. The horizontal number line is where the x values go, or it represents where the x values are. And the vertical number line is where the y values would be represented, okay? So in this case, I would say, well, horizontally we got this purple, that's x, and vertically we got green, which is the y values, okay? Now these are called axes. So in 980, And we'll get a little reference to this, but there's not very much sections left. This is called the x-axis, the horizontal number line, and the vertical number line is called the y-axis. And in the middle, like I said, you wouldn't really see 0 right there. That's 1 right there, so we do need that. But right in the middle here, that's where x is 0, 0 on the x number line, the x-axis, and it's 0 on the vertical number line, the y-axis. Now, in some cases, you'll see an O like that, right? And I've got that in red on purpose. And a lot of students mistake that O for a 0, but it's actually the letter O, because right in the middle there, that's actually called the origin. All right, and there may be some questions on the homework where you need to know that the middle there is the origin. So again, this would be my x-axis, and that's my y-axis. I'm labeling this stuff because we do need to know it for the homework. Now, you can see that the two number lines, the vertical number line, the y-axis, the horizontal number line, the x-axis, has separated this slide into 4 parts. Okay, now we call these quadrants. So we're going to be looking at the different quadrants. Quadrants. Hopefully I spelled that right. Quadrants. Now it doesn't go probably like you would expect, which would be clockwise, starting in the top left corner. And we usually use Roman numerals to represent the quadrants. The first quadrant is actually where the x values are positive and the y values are positive. So that's quadrant 1 in the top right. Now it actually goes counterclockwise. So we need to be careful with that. If we can just know where quadrant 1 is and then know it goes counterclockwise from there, hopefully we can remember where the quadrants are. So counterclockwise shows this is quadrant 2. Continuing counterclockwise, this is quadrant 3. And then this is quadrant 4. So we can see that in quadrant 1, the x and y values are both positive. In quadrant 2, now we're in the negatives for x values, or on the x-axis, while the y-axis is showing positive. So this would be a negative-positive relationship. In quadrant 3, now our x values are negative, but also our y values are negative here. So for quadrant 3, both the x and y values would be negative. And in quadrant 4, we see a positive value on the x-axis and negative for the y-axis, so that's a positive-negative relationship on that one. All right, the last thing on this one is actual coordinate pairs. I'm going to write that in there. Let me change that so it's out of the way. There we go. All right, that'll work better. So, on this one, I can see that this point is on this line that's vertical, and then it's on this line here that's horizontal as well, okay? And yeah, I know my lines aren't exactly straight, but that's kind of how I'm looking to line these up, okay? And you'll be given a grid, which we'll see here in just a second. So, what value of x does this blue point correspond with? Well, I just follow this purple line down to the x number line, and I see that it's has a value of, well, that'd be 0, -1, -2. So that's where -2 is, which means the x value in the coordinate pair is also -2. Well, then I see what is its corresponding y-axis vertical line value. And again, I follow this green line over here, and it's showing that it corresponds with, what is that, on the vertical number line, that's 0, 1, 2, 3. So that would be 3 right there. And that gives us this ordered pair of -2, 3. Now again, they do need to be in parentheses with a comma between them. So if in the future they said, well, what is the value of that coordinate pair, that point right there? And you said -2, 3, with no comma, you'd lose credit. If you only put a comma, you lose credit. Because, again, it needs to have the set of parentheses on this. And the parentheses with the comma helps us to know that we are dealing with an ordered pair on this. So for this example, identify the location and coordinates of the following points. So there's two parts to this, and we'll discuss both of them. So the location is asking what part of the graph is this on, or the coordinate, the Cartesian coordinates, okay? So I look at A, right? Let's start with A. I first need to find it on the graph. There it is, top rightish. Let's look at the coordinates first. So again, I know the coordinates need to be in an ordered pair, parentheses with a comma, right? And the first value in an ordered pair is always the x value. So again, I follow this down and I see it corresponds with an x value of 4 on the horizontal number line, the x-axis. And the vertical axis, it corresponds with that value 3. So its coordinates are 4, 3. Its location, so we're looking at labeling it. Is it in a quadrant? Is it on an axis, or maybe at the origin? The coordinates for A are in quadrant 1. So I'm just going to put that Roman numeral 1 right there. So that answers both parts. We have the location and the coordinates, even though I have them out of order. Next up, we'll do B. So again, I need to find B on this graph. There it is. We'll start with the location on this one. This one is directly on the y-axis. It's on that vertical number line, which means it's not actually in a quadrant. It's just on one of the axes. So I'm going to say it's on the y-axis like this. And again, I want the coordinates for it. So I start with the x value because it's always the first one in an ordered pair. And I follow it up to the number line, the horizontal number line. And it's not showing me a value because it's right in the middle there, which means it's at 0 on the horizontal number line. And its vertical number line is already showing where it is. It's at -2. So its ordered pair is 0, -2. Next up, we'll go to E. So again, I find E on this graph. And E is right in the middle. Okay, now we need to remember numbers right in the middle. That's called the origin. That's where the two number lines come together. It's called the origin. And what is the coordinates or the ordered pair for the origin? Well, it's at 0 on the horizontal number line, and it's also at 0 on the vertical number line. So we got 0, 0. It's right at the origin. And then finally we'll end with F. So again, I find F on the number, well, it's on this number line, the horizontal number line, which is the x-axis. And what are its coordinates? Well, we can see its horizontal line coordinate, which is 4. And it has, again, I'm just following this line back to the vertical number line, and that's right in the middle of it, which means that it's a 0 value on the y-axis. So it's 4, 0 are its coordinate or ordered pair. All right, for these ones, we'll identify the location of these ordered pairs. Alright, so just as a quick review of what we saw a couple slides ago, we have a vertical number line and a horizontal number line. The vertical number line is called the y-axis. Horizontal number line is called the x-axis. And right in the middle there we have the origin. And then we start in the top right, which is quadrant 1. And then we go counterclockwise 2, 3, and 4 like this. So the orange Roman numerals are the quadrants. Now, like I was telling you guys, as in ordered pairs, quadrant 1 has x values that are positive and y values also that are positive. Quadrant 2 has x values that are negative and y values that are positive. Quadrant 3 has negative x values and negative y values. Quadrant 4 has x values that are positive and y values that are negative. Okay, and again, that has to do with the relationship between where the quadrants are with the number lines, okay? Because again, if I look at x to the right of 0, that's all positive, and y upwards would be positive. Again, that's a positive relationship here. And quadrant 4 would be positive, negative, because the y values are now negative. So we can kind of identify where these coordinate pairs would be on the graph. They don't have to be exact either, by the way. Okay. So like negative 41, 15, right? So negatives, that'd be negative for x, but positive for y. So negative 41 for x, positive 15 for y, which means, you know, maybe it's somewhere in this area, showing that it's in quadrant 2. Right there. 18, 0, so that's an x value that's 18, somewhere over here, that's positive. But the y value being 0 means it's right on that x number line, which is the x-axis. Now negative 21, negative 12, that's negative for y, but also, I'm sorry, negative for x, but also negative for y, right? So negative 21, negative 12, you know, maybe somewhere in this area. And that shows that it is in quadrant 3, right? And finally, 13, negative 51, so that's positive for x, positive 13, and negative 51, that's our y-axis, that's a negative 13, negative 51, you know, well, maybe somewhere down here, which shows that it's in quadrant 4. So we've identified the location of these points. Now in the future, they're actually going to ask us to graph these, which we'll get into. So you may see ordered pairs like this. Okay, now looking back, we need to remember that it's actually just set up like this, okay? Now for ordered pairs, remember that it's always the x value first and the y value second. So on this one, 2, negative 4, okay? So I find where x is 2, right here, on the horizontal number line. And y, that's the y-axis, that's our vertical number line, that shows negative 4, right? So I'm looking at negative 4 here. The point is going to go where these two lines connect, okay? So I just follow negative 4 over and positive 2 down, which gives me this point right here. So clean that up a little bit. There it is. That's our first point. We'll just color coordinate these so that hopefully it kind of makes sense which ones are which. Next up, negative 3, negative 5. So I find negative 3 on the x number line and negative 5 on the y number line here and here. And again, I'm just following these until they meet together to give us this point here. Now 0, 2. So I Find 0 on my x number line right here, 2 on my y number line right here, and again, they're just going to come together right on the y-axis. So we get that red point right there. And finally, negative 1, 1. So I find x is negative 1, y is 1. We just bring those together, and we get this point in orange there. Now on the homework, you're just going to be clicking these in. So from Module 2, Section 3, or just 2.3, remember that a solution to an equation is a value for a variable that makes the equation true. So with one variable, when it said solve for x, it really meant, what value of x makes the equation a true statement. With two variables, when it's going to say something like select all points that lie on the graph, which really means what x and y values will make this equation true. So in the last section we saw, let's just look at a kind of a basic equation like this, right? Y equals, I don't know, we'll say 2x plus 1, okay? Now looking back at 2.3, remember that if we have two numbers that are equal like this, then we're in pretty good shape, right? And in fact, if we were to manipulate this and say, well, 5 could be really represented as 2 times 2 plus 1, right? 2 times 2 plus 1 is 5. And this would still be a true equation, right? Well, if we got rid of that 2 and replaced it with an x, now we have a two-step equation, which you would then solve x, or for x. Now we know that's 2 because we just replaced it, and it would give us a true statement. But what they're doing now is they're saying, well, instead of this only being 5, we're going to replace that also with its own variable like this, okay, which is the same equation that we see in the top right, which brings up a question, you guys. On this one, we just knew from replacing the value x is 2, y is 5, right? But is that the only values of x and y that would make that true? And hopefully you're realizing, since there's two variables now, that the answer is that there is more. There's more values of x and y that would make this true, okay? Here's what I mean. If I were to go into this equation, and let's say I replaced x with, let's say, 0. Well, what value of y would then make it a true statement? Well, it becomes an equation that I could solve. That's a 2 times 0 plus 1. And 2 times 0 is 0, plus 1 is y. 0 plus 1 is 1. Okay? So, again, I remember I told you guys this creates a relationship. We've already shown this down here, that it would give us the ordered pair. X is 2, y is 5. But over here it gave us a whole different ordered pair where x is 0 and y is 1. Which means that this ordered pair, 2, 5, would make this equation true. And this ordered pair, 0, 1, also makes this equation true. So there's actually an infinite number of possibilities of x and y that correspond with each other that would make the original equation, y equals 2x plus 1, a true statement. Now, we don't have to find all of them because there's an infinite number. But you should have to find at least 2 of them, okay? Because if we were to go back and say, well, look, 2, 5, and 0, 1, could you put that on a graph? Hopefully you feel like you can by now, okay? Because we're going to be needing to in the future. So let's look at an example of this. Determine whether the given points on the graph of y equals negative 2x plus 5 or are on the graph. So in other words, this is really saying, does the ordered pair 3, negative 8 make this equation true? Well, let's find out. So I've got this equation rewritten, and we're replacing the x and y values, and again it's important to remember which is which. So my x value is 3 and my y value is -8. So it's -8 equals -2 times 3. Well, we're not sure if this is true, but we're going to find out. So I got a question mark over my equal sign. Now -8, it's just -8, that's fine. And we're seeing if this does equal. -2 times 3 is -6. But when I add 5 to that, I end up with -1. Well, is that true? No, it is not. So 3 -8 would not be on the graph of y equals -2x plus 5. Well, what about -3, -1? So again, -3 is x, -1 is y. So I got -1 equals -2 times now -3 plus 5. Well, this one's going to be close, and I'll put a question mark over my equal sign. Does -1 equal this? Well, -2 times -3 is +6. Well, +6 plus 5 is 11. So these also are not equal, which means that it's not a true statement. So no, -3, -1 would not be a solution for that equation. Well, let's see if the next one is. So again, I've got this set up so I can replace the values. Again, -1 is x, 7 is the y. So I replace them in the equation. Y is 7, x is -1. And again, another question mark, so I don't know if these are equal yet. 7 is just 7, that's pretty nice. And eventually, yeah, you may have to do some work on the left side, but that's okay. And over here, I got -2 times -1, which is 2. 2 plus 5 is 7. This one is a true statement. So -1, +7 would be on the graph of y equals -2x plus 5. And then this final example, y equals 2 times x plus 5. Again, the x is 0 in this case, and the y value is 5. So I got 5 equals 2 times 0 plus 5. And we'll see if this is true. So 5 is just 5. 5 equals 2 times 0 is 0 plus 5 is 5, you guys. So that is true. So 0, 5 would be on the graph of y equals -2x plus 5. Now what this means is that if we were to look at a graph with our two axes, x axis and y axis, I could graph these 2 points, the -1, 7 and the 0, 5, right? So -1, 7, well, that's up here somewhere, and 0, 5, maybe right here. And that creates a relationship between these 2 points. And to show all the values on a graph like this, whereas right now I got 2, they create a relationship. All of these are going to create straight lines for us. That's not perfectly straight, but it'll do. So we see a relationship like this one, like this blue line, which we could then put on a graph. Okay, so where these 2 values were true, they're on the line, but all the points on this line would make this equation true. And again, we'll see this in a little bit more detail as we look at the grids. In the future, for problems like this one, they're not going to give you the ordered pairs, and not even to try out. Okay, which means that you're going to have to choose one of the values, and it could be x or y, and then you have to solve for the missing value. And while that may not make a lot of sense right now, hopefully it will by the time we finish 7.3. So here's the other format, and again, this is just like evaluating the formula given x and y values, just like we did in 7.1, right? So we start with the equation. So x minus 2y equals 4. But we're replacing the x and y values individually, right? So x is 2 in this case, and y is -1. So the y value is -1, and the x value is 2. And we're seeing if this equation is now true. Now right here I got 2 times -1, which would be -2. So I got -2 minus -2. That's really 2 plus 2 is 4. Well, that does equal 4. That's true, which means that this ordered pair is actually part of the graph for x minus 2y equals 4. And just again, real quick, this means that if I were to graph this equation, the ordered pair we just saw, 2, -1, so there's 2, -1, would actually be on the graph right there. Well, we'll see some decimals like this also. So I'm just going to set up the equation, replacing the x with 1. So I got 1 minus 2 times the y value, which is -1.5. And then we see if this is true. So 2 times -1.5, that's going to give us a -3. So I got 1 minus -3, which is really 1 plus 3. That's 4. 4 does equal 4. That's true. So that answer is yes. And when I go to my graph, I see I got x is 1 here and -1.5. That'd be about right there. Okay, now I could connect these dots, but let's see if this last one is true also. So I got x minus 2 times y equals 4. We'll see if this is true, where x is 0 and the y value is -2. So let's see if this is true. Well, I'd have 2 times -2, which is -4. Now that's 0 minus -4, you guys, which really makes that 0 plus 4. So that's 4 equals 4, which is true. So this one also, and it's rare to see this, but it does happen from time to time, where all the values in a set are actually going to make the equation true. So 0, -2 is right there on the number line. We can see that that creates some consistency for us. It would look better if I used a grid, but that looks okay. All right, if we connect those points, it creates a straight line. Now this brings up a question for us when we're graphing an equation, right? And this orange line represents this equation, okay? So remember, I told you there's a couple ways to represent it. An equation is one way to represent a relationship, but a graph is also a way to represent relationships. So the orange equation and the orange line are exactly the same thing. They're just shown in different ways. Well, that brings us then to 7.3, and that's all it's going to be in 7.3. You got to put these points on a graph, and then you connect the points. So, this is what I was gonna say. Is some of you guys know to make a straight line, you only really need 2 points, right? Any 2 points will make a straight line. But in 7.3, when you guys are drawing your lines, we're making these graphs, these straight line graphs. I recommend using a 3rd point just to make sure you're doing your math correct. And the reason for that is because if you go to graph a line, if you go to graph a line, this is my 2 axes, right? This is my x-axis. That's my y-axis. Well, if you go to graph a line and your equation, you solve and you get this point right here. It doesn't matter where. And you solve the next point, you get this one. And you're like, look, I can make a line through 2 points. Again, that's a straight line, and that looks pretty good. But if you found a 3rd point, and it's up here, it should fall on that red line, right? But since this orange point is not on the red line, it's like, well, should you connect these two? Should you connect these two? We just never know until you check your work. Okay, so the third point is really meant to allow you to see that there's a pattern, because if instead of being right there, right, let's erase this garbage, like you solve for your third point and you found that it is on that red line, okay, then the pattern is consistent and you can know that your answer is correct. Keep this in mind for the next section because it's going to be crucial. A lot of students they'll do the 2 points, okay, because you have to do 2 points to make a straight line. But to check it with the third point is it's a skill that not a lot of students are willing to put the time into. And it is good practice to help you guys remember how to graph points. But it will also help to ensure that your line is correct.